Welcome back to my YouTube channel Grandpa Mathematics. Today we'll do problems in miscellaneous exercise on application of integration. So to find the area of this region bounded by this curve y is f of x and the lines x is equal to a and x is equal to b and x-axis will be using the definite integral a to b f of x dx. Integral a to b y dx, y is nothing but f of x. In this problem, we have to find the area under given curves and given line. Given curve is y is x square and lines are x is equal to 1, x is equal to 2 and x-axis. Y is equal to x square is an upward parabola with the vertex at origin as shown in the figure. Now, the equation of y-axis is x is equal to 0 and x is equal to 1 is a line parallel to y-axis as shown in the figure. X is equal to 2 is again another line parallel to y-axis. Now we have to find the area bounded by this curve y is equal to x square and the line x is equal to 1 x-axis and the line x is equal to 2. Let A be the required area. A is equal to integral x is equal to 1, x is equal to 2. Therefore, x varies from 1 to 2 and the equation of this curve is y is x square. F of x is x square. So, x square dx. So, we have to express y in terms of x, that is nothing but f of x. On integrating, we get x cube by 3, 1 to 2. So, this is nothing but 1 by 3. We will substitute the upper limit for x. So, 2 cube minus 1. So, 8 minus 1, 7, 7 by 3 square units. So, this is the answer. We have to find the area bounded by the curve y is x power 4, the lines x is equal to 1, x is equal to 5 and x-axis. First we will draw the graphs of these lines. X is equal to 1, equation of y-axis is x is equal to 0. So, x is equal to 1 is a line parallel to y-axis and x is equal to 5. Now, in this curve, y is equal to x power 4. On solving this curve with this line x is equal to 1, put x is equal to 1 here. So, y also 1. So, 1 comma 1 is the intersection of this curve with the line x is equal to 1. 1 comma 1. This point. Now, to see where this curve intersected this line x is equal to 5, put x is equal to 5 in this equation. And x is equal to 5 gives y is equal to 5 power 4. 5 power 4 is 25 into 25, 625. So it will be 5 comma 625. So we can join, and in this equation you put x is 0, y is also 0, so the curve passes through origin 2. So the equation of curve is y is equal to x power 4. Now we have to find the area of the region bounded by this curve. X is equal to 1, x-axis, and x is equal to pi. A be the area bounded by this curve, x is equal to 1, x is equal to 5, and x-axis. A is equal to, now we have to see the limits of the finite integral. X is 1, x is 5. So that is x varies from 1 to 5. And the equation of this curve is y is x power 4. So x power 4 dx. F of x. Y is nothing but f of x. F of x is x power 4. So this on integrating will get x power 5 by 5, 1 to 5. This equal to 5, for x will substitute the upper limit, 5 power 5 by 5 minus 1 by 5. So 5, this will be 5 power 4, 5 power 4 is 625 minus 0.2 is equal to 624.8 square units. So this is the answer. You have to find the area between the curve y is equal to x square and the line y is equal to x. So x square is equal to y is a upward parabola with the vertex at origin as shown in this figure. And y is equal to x is a line passing through origin, and we have to see where this line intersects the parabola. Solving the equation 1 and 2, we will get the intersection point of this parabola with the line. So the line and parabola intersect at x is 0 as well as x is 1. When x is 1, the value of y also is equal to 1. So the intersection point is 1, 1. The x coordinate of the intersection point is 1. Therefore, the equation of this line is x is equal to 1. Equation of y-axis is x is equal to 0. Now, we have to find the area between the line and the parabola. Let A be the area between the line and the parabola. Therefore, A is equal to, now we have to find the limits of the definite integral. X varies from 0 to 1. X is equal to 0, x is equal to 1. X varies from 0 to 1. Now we will take this upper curve. y is x, so x dx minus integral 0 to 1, the equation of parabola is y is x square, so x square dx. Since the limits of both integrals are same, we can write the integral x is 0 to 1 x minus x square dx. On integrating we will get x square by 2 minus x cube by 3, limit 0 to 1. So 1 by 2 minus 1 by 3, you are substituting the upper limit for x, and lower limit if you substitute 0 only comes. So minus 0 is equal to 1 by 6 square units. So this definite integral 0 to 1 x dx, this gives the area of this region, area of this triangle. This gives the area of the triangle, and integral 0 to 1 x square dx, this gives the area below the parabola, and this is the area. So from the triangle, if you subtract this area, we will be getting the area in between the line and the parabola. In this problem, we have to find the area lying in the first quadrant and bounded by this parabola 4x square is equal to y, and the line x is equal to 0, y is equal to 1, and y is equal to 4. Y is equal to 4x square. We can rewrite this as x square is equal to y by 4 is an upward parabola with the vertex at the origin, as shown in the figure. Now, x is equal to 0 is the equation of y-axis. X is equal to 0 is the equation of y-axis. Y is equal to 0 is the equation of the x-axis, and y is equal to 1 is a line parallel to x-axis as shown in this figure, and y is equal to 4 another line parallel to x-axis as shown in this figure. So we have to find the area in the first quadrant, and bounded by this parabola and the line y is equal to 1, x is equal to 0, that is y-axis, and y is equal to 4. So this area we have to find. Here you can see y varies from 1 to 4. Previously x varies from a to b. Here y varies from y is 1, y is 4. That is y varies from 1 to 4. Then we have to find the value of f of y, that is x in terms of y we have to find. So x square is y by 4. So this gives the value of x is root y by 2. X is equal to root y by 2 is the equation of this parabola. Let A be the area of the region bounded by the parabola and the lines y is equal to 1 and y is equal to 4 on y axis. Therefore, A is equal to, now we have tried the definite integral y is 1, the lines, equation of lines are y is 1 and y is 4. That means y varies from 1 to 4. So, y is equal to 1 to 4, then dy. X varies means dx will come, y varies means dy. Dy means change in y, then x dy. X is nothing but f of y. So x is what now? Root y by 2. So root y by 2. Here integral y varies from a to b, x dy. X value is root y by 2. X is nothing but f of y. So on integrating we will get 1 by 2. On integrating root y power half, we will get y power half plus 1 by half plus 1. That is y power 3 by 2 by 3 by 2, limit 1 to 4. So this 2 and 2 gets cancelled and we will be getting 1 by 3 times. Now for y we will substitute the upper limit 4 power 3 by 2 minus lower limit 1. So this is equal to 1 by 3 times 4 we can write as 2 square. So 2 square power 3 by 2 minus 1. So 2 and 2 get cancelled. 2 power 3 is 8. 8 minus 1 is 7. 7 by 3. So 7 by 3 square units. So this is the answer. So in this problem we have to sketch the graph of this equation y is equal to modulus of x plus 3, and hence we have to evaluate this definite integral. So y is equal to modulus of x plus 3. Now we have to remove the modulus. Equate x plus 3 to 0. X plus 3 is equal to 0 gives x is equal to minus 3. Therefore, we can write, therefore, y is equal to x plus 3 when x is greater than or equal to minus 3. Y is equal to modulus of x plus I remove the modulus when x is minus 3, when x is greater than or equal to minus 3. So we will take a number greater than minus 3. So we will take minus 2. Minus 2 plus 3 is 1. So positive value we are getting. Again, this equal to minus of x plus 3 when x is less than minus 3. So we will take a value less than minus 3. So minus 4 is less than minus 3. So we will substitute here. So y is what now? Minus of x is minus 4 plus 3. Minus of minus 1 is equal to plus 1. This way we are getting a positive value. Y is equal to x plus 3 if x is greater than or equal to minus 3. And y is equal to minus of x plus 3 when x is less than minus 3. To draw the graph, we should get points. Case 1, y is equal to x plus 3. Put x is 0. X is 0, we will get the value of y is 3. Then x is minus 3 is there. Put x is minus 3. Minus 3 plus 3, y is 0. Case 2, y is minus of x plus 3. Now again, put x is minus 3, one value. Minus 3 means minus 3 plus 3, 0. Then you put minus 6. Because here our definite integral, one of the limit of the definite integral is minus 6. So you put x is minus 6. Minus 6 plus 3 is minus 3. Minus of minus 3 is plus 3. So now we can draw the graph. So x is minus 3, y is 0. So this point is minus 3, 0. X is 0, y is 3. X is 0, y is 3. So 0, 3 is this point. So on joining these two, you'll get the equation of this line is y is x plus 3. Now, when x is minus 3, y is 0, minus 3 is 0. When x is minus 6, y is 3. So we'll take this point is minus 6, 0. Minus 6 means y is 3. So we'll join these two. So y is equal to is the equation of this line. So equation of this line, when the x coordinate of this point is minus 6, so equation of this line is x is minus 6. Equation of this line is x is equal to minus 3. Equation of y-axis, x is equal to 0. Now we have to evaluate this definite integral. Integral minus 6 to 0 modulus of x plus 3 dx. This equal to minus 6 to minus 3. We have one equation. Minus 3 to 0 we have another equation. So we have to write this, we have to split this integral minus 6 to minus 3 modulus of x plus 3 dx plus minus 3 to 0 modulus of x plus 3 dx. In minus 6 to minus 3, the equation of this line is y is minus of x plus 3. So here minus of x plus 3. So we have to put a bracket dx plus here just we can remove the modulus minus 3 to 0 x plus 3 dx. Here we can take minus sign outside. Minus sign outside. On integrating x, we will get x square by 2 plus 3x. Limit minus 6 to minus 3 plus again x square by 2 plus 3x minus 3 to 0. Now for x we will substitute the upper limit. So minus x upper limit is minus 3 x square minus 3 square is 9. So it will be 9 by 2. Then plus 3 into minus 3. So minus 9. Then minus of, for x you have to substitute the lower limit. Minus 6 whole square is 36 by 2 is 18. Then 3 into minus 6 is minus 18. 3 into minus 6 minus 18 plus, if you put substitute the upper limit for x is 0, it will become 0 minus, for x substituting minus 3. So 9 by 2 minus 3 into minus 3 is minus 9. Nine by 2 plus 9 by 2 is equal to 9. Answer. In this problem, we have to find the area bounded by y is sin x between x is 0 and x is 2 pi. So graph of y is with sin x is shown in this figure. So equation of y-axis is x is equal to 0 and this is pi and this is 2 pi. Through pi and 2 pi, we will draw lines parallel to y-axis. Equation of this line is x is equal to pi and equation of this line is x is equal to 2 pi. A be the area bounded by the curve y is sin x. Therefore, A is equal to integral 0 to 2 pi. 0 to pi, the curve is in the first quadrant. So that means we can write x is 0 to pi sin x dx. To find the area of this region, x is 0, x is pi and equation of this curve is y is sin x. And how to find the area of this region? Again, integral x is pi, x is pi, x is 2 pi, again sin x dx. But if the curve is below the x-axis, we will get the areas negative, but area cannot be negative, so you have to take the modulus. When the curve is below the x-axis, then you have to take the modulus because area cannot be negative. So this is equal to, on integrating sin x with respect to x, what will get? Minus cos x 0 to pi plus modulus of minus cos x pi to 2 pi modulus. So minus cos of minus is plus, cos 180 is minus 1. So this will be 1 plus 1, 2. Minus 2, when you take modulus, that will become plus 2. So 4 square units. So answer we have to find the area enclosed between the parabola and the line. Y square is equal to 4ax is a right-handed parabola with the vertex at the origin as shown in the figure. Y is equal to mx is a straight line passing through the origin. To see where this line intersects the parabola, we have to solve the equations of the line and the parabola. To get the value of x coordinate, we will square this, then equate the both equations. So this gives y square is equal to m square x square. Therefore, y square is equal to 4ax is equal to m square x square. Here we should not cancel the variable x. So take x outside. 4a minus m square x is equal to 0. So this gives the value of x is 0 or m square x is equal to 4a, that is x is equal to 4a by m square. So we need to know the x coordinate of the intersection point of the line on the parabola. We need not find the y coordinate. So the line passes through origin and x coordinate is 4a by m square. X is 4a by m square. Equation of y axis is x is equal to 0 and this line x is equal to 4a by m square. So on joining these 2 points, so this is nothing but y is equal to mx. And now we have to find the area of this region. Let A be the area enclosed by the parabola and the line. A is equal to, now x is 0, x is 4a by m square, integral x is 0, x is 4a by m square. Now we will take the equation of this curve. What is the value of y? Y is 2 root a root x. So 2 root a root x dx, then minus integral x is 0 to 4a by m square. Equation of y is mx dx. Or instead of writing separately, because for both the curves the limits are same, so we can write this directly, minus mx dx, because for both the curves the limits are same. Now we'll take 2 root a outside. On integrating root x, what will get? X power 3 by 2 by 3 by 2 minus m x square by 2 0 to 4a by m square. So this will be 4 by 3 times 4 by 3 times root a. Now for x we'll substitute the upper limit. X power 3 by 2 is there. I will write this x into root x. For x I will write 4a by m square. This is for x. For root x, then 2 root a by m. So this whole thing for x power 3 by 2 minus m by 2 x square. We have to square 16 a square by m power 4. Here x is 0 to 4a by m square 2 root a root x dx. So this gives the area of this region, this curve. This region integral 0 to 4a by m square mx dx. That gives the area of this triangle. So from the whole thing, from this area, if we subtract the area of this triangle, we'll get the area enclosed between the parabola and the straight line. So this is equal to 1 by 3. 4 by 3 minus 1 by 3. So 8 by 3 times a square by m cube square units. So this is the answer. 8 by 3 a square by m cube.